sines and cosines to prat about with, and then you use Pythagoras, and then you do a square root and take an arc sine of that. Okay, so that's the trigonometry. If you understand that, you'll realise that the first step is got a whole pile of sines and cosines to find the x, y and z coordinate of your point. Before you can use Pythagoras' theorem, you should compute those x, y and z before you start. Then you have not got to bother every time you want to manage a distance. So it cuts the distance calculation by about a factor of 2. And then there's what I call the, maybe I shouldn't have called it that, but anyway, I've called it the squared normalised mole distance. You don't need to calculate the distance for all of this. It is sufficient to know how far the x and how far they are in the universe through the Earth. I call that the mole distance. As the bird flies, as the mole digs. Okay? It's the mole distance, and I haven't bothered to square root it. That square root doesn't make any difference either, so don't bother with it. And then I haven't bothered to multiply it by the radius of the Earth. All of these save time. You can work with the squared normalised mole distance throughout. Of course, you want points that are within 5 kilometres, so I have to convert 5 kilometres into a squared normalised mole distance at the start. And that's one of the calculations you do at the beginning of the search. And I'm holding my distances as 16-bit integers because this, very important to the size of a pot, is how many distances you store. 16 bits is 300 metres. I'm hoping that's enough. If it isn't, I'll be changing it. So if you want to use my software to calculate the nearest 3 people to you, I'm afraid he's going to get considered because he's within